I'm gonna sneeze. No, hold on. Just kidding. Let's talk about the gears, pulleys, and drives, pulley drives, and sprockets, and chains, and stuff. What are these things? So they're power trains that transmit energy through rotary motion. It just spins it like a circle. It just spins around. You could change the speed of rotation with a gear train or a sprocket and chain or a pulley system. You can change the direction of rotation by adding more gears. And you can change the amount of torque available to do work. It's amazing. What is this stuff? This is a motorcycle. Look at that. This is chain and sprocket. This is like a pulley system. I can't really tell what that is. And it looks maybe like it's opened up engine. Yeah? I don't know. Alright, gears. You know what really grinds my gears? Nothing. So, gears are just like wheels with teeth. They don't bite though, because it's not like that. That doesn't have a mouth. And if you spin this way, this one will spin the other way, right? It spins and it makes this one spin the other way. Okay. A gear train is made when two or more gears are meshed together. Drive gear causes the motion, so the drive gear is the input gear. That's the thing that either the motor is spinning or you are spinning. Motion is transferred to the driven gear. So the driver gear is where you're putting the torque. You're inputting the motion, and then the driven gear is the output. Moving right along. This is all hopefully things that you can like, oh yeah, my bike has that, if you have a bike. So mating gears always turn in opposite directions. If this spins this way, these teeth force the other gear to spin in the opposite direction. So this would be clockwise, and this would have to spin counterclockwise. An idle gear is just a gear that's placed in between two other gears. The idle gear allows the two other gears to spin in the same direction. So here they spin in opposite directions, but with this, if I spin the first blue gear that way, the red gear will spin the other way, right? And then the blue gear on the right side will spin in the same direction as this first one. So idle gears allow the gears at the ends to spin in the same direction. Mating gears always have the same size teeth. So diametric picture. We'll just talk about the number of teeth. Usually for the things that we build, all the teeth mesh together nicely. They gotta have the same size teeth. Any questions? No, of course not. This is a video. Actually, you could raise your hand and ask a question, or ask me a question in class if you want. Yeah. What's next? Gears still. Well, that makes sense. The RPM of a larger gear is always slower than the RPM of the smaller gear. Okay, RPM, in case you don't know, is revolutions per minute. So like oh no, I spilled a cup of pens. All right. If you see on your car the tachometer in your car, it tells you how fast the engine is spinning. The RPMs in times 1,000. There's thousands of RPMs. So that's what that is. Gears locked together on the same drive shaft or on the same shaft will always turn in the same direction and at the same RPM. Okay, so like if this yellow gear is spinning and it's attached on the same shaft as this blue gear, the blue gear is going to spin at the same speed as that. RPM is like the speed at which it's spinning. So there you go. Moving on. Why would you have this kind of gear train right here? Well, maybe you're trying to spin this gear, and if you try and spin it, this is going to have a slower RPM than this. So like you spin this, and then this little one spins that over there. It also changes the direction, so you can spin it this way, and then have this gear spinning the other way. We'll talk about that when we build stuff. So how do we talk about gears? We talk about gear ratios. Usually for the simple machines, we used mechanical advantage.
we can kind of think of gear ratios as a sort of mechanical advantage for gears. The things to know are the N is the number of teeth. These are teeth. Those things. There's those teeth. The diameter is just from the one tooth to the other one directly across. The angular velocity, usually you write it as like a omega. Omega. It's a curvy W. Angular velocity. And the torque. So these are all things that you can use to calculate gear ratios. And I will show you the important things. So like if this is the input gear, meaning you're spinning this gear, this would be the output gear. If you're rotating at 40 RPM, then, well actually I think we talk about it in the next slide. We use the subscripts in and out to determine or to signify which is the driver and the driven gear. So this is how you calculate gear ratios. Equations to know. Look at that. The gear ratio is gear ratio over 1. That's going to be the number of teeth out of the output gear and the number of teeth in the input gear. Same with the diameter of the output gear and the input gear. So for the number of teeth or the diameter, it's out in. To calculate the gear ratio using speed, the angular velocity, you use the velocity of the input gear, so it's kind of backwards, input gear, output gear. And then this one is back to normal. Torque output and torque input. So this is like for this gear train, what would we have? The number of teeth of the output gear. So if we want to calculate the gear ratio using any one of these formulas, we just follow them. You could actually write these as what 1, 2, 3, 4 separate formulas, but we just write them all equivalent to each other, and then you just write it once. So the gear ratio for the number of teeth out, that would be, well, how many teeth are here? Did it say in the other one? I think it did. Number of teeth, 6 or no 12. Or you could just count them, but I don't want to count them. So that would be 12 teeth, and then the number of teeth in the input gear is 1, 2, 3, 4, 5, 6. So the gear ratio should be 2, right? 12 divided by 6 is 2. Or you could do it by the diameter. The diameter of the output gear is 4 divided by 2 is still 2. So that's beautiful. The angular velocity, well, of the input gear, remember we do this one backwards. The input gear, that would be 40 over 20, which is still 2. Everything's good. Life is good. And then the torque. Well, we don't know. But look at there. There we go. This stuff would be measured. So they tell us the torque in and out. That's what a hamburger is all about. Out was what 80. So 80 foot-pounds. And then no foot divided by pounds. Divided by the torque of the input gear would be 40. So everything works out. Oh, I didn't put my units on my other stuff. Angular velocity, what was the velocity? RPM. So this would be RPM. The diameter, what was that? I guess it didn't say. Inches? No. Yeah, inches. So make sure you put your units. And then the number of teeth, I'm not going to write that. Just teeth. Okay, so, yeah, that's how you calculate gear ratio. Those formulas are going to be useful. So you're going to have to figure out what you need for all of those. And I'm going to stop this video because it's going really long.